Thank you so much. I will share my screen now. Oh, wait. Okay. Do you see my screen?
Yes.
Yes. Thank you so much. And it's recording. Okay. Yeah. So hello, everyone. My name is Mari Hayashi, and I'm a fourth-year computer science major at UCR. Today, I will talk about my research, relationships between background music and cognitive control. I conducted this research as a capstone project submitted for graduation with university honors. And my faculty mentor, Professor Aaron Seitz, helped me a lot on designing and conducting the research study. So I'd like to give him a special thank you. So first, I will introduce the purpose of this research. So using the raise hand feature on Zoom, please raise your hand if you don't listen to the music when you study or when you are working. Yeah, thank you. So as shown here, there are some people who listen to the music when they study and some people who don't listen to the music when they study. The purpose of this research is to explore how the background music affects performance on various tasks. Many past researches investigate the effect of music on our brain performance. For example, a research paper done by Dimitri and other researchers found out that listening to music produces flow state, which is a mental state that his or her complete attention is focused on their task. On the other hand, a research done by Janki says that they didn't find any significant influence on background music on verbal learning. So many researchers investigate the effect of music on our brain performance, but it is unclear if listening to music while working on our task really helps us working on the task or not. Therefore, in our research, we investigated if listening to music helps our brain working on simple tasks. The findings from this research would help our community create an environment that allows people to effectively work on their task at office or library. So I will now talk about method. In order to investigate if listening to music helps people or not, I developed a mobile application game using Unity, game development platform, and C#, a programming language. The mobile application gives the player 3 simple tasks: memorization, attention, and calculation tasks. And we recruited 48 undergraduate students at UCR and had them play each task on their phone with and without the music and compared their performance. Out of the 48 participants, 34 participated in the research remotely due to the COVID-19 spread and the campus closure. At the beginning of the training, we asked each participant to fill out a short questionnaire to collect their background information, including age, race, and if they usually listen to the music while working on school assignment, exercising, or doing housework. This is how the demographics of the participant looks like based on the questionnaire. Most participants are in age between 18 to 22 because we asked undergraduate students at UCR to be a participant. Participants completed 3 training sessions more than 1 day apart. Each session took 30 minutes and participants worked on each task sequentially within the 30 minutes. Also, each day, the participant worked on the task in different background music conditions. The first condition is no music, where participants work on the task without listening to any type of music. The second condition is binaural beat. Participants work on the task while listening to binaural beat. Binaural beat is not type of music, but it occurs when 2 sounds of different frequency are released in the headset, each of 1 ear. The positive effect of binaural beat is supported by Firmon. According to his research, binaural beat creates consciousness states and improves creative capacity and improve sleep and promote relaxation. In the last condition, participants worked on the task while listening to a classical music composed by Wolfgang Amadeus Mozart. Rorschach's research shows that classical music has positive effect on our brain because his research participants achieved a higher IQ score when they are listening to a music composed by Mozart. So this is a training schedule of the first participant. For example, on the first day, he first worked on the attention task for 10 minutes in no music condition and work on memorization task for 10 minutes in binaural beats condition, and then work on calculation task for 10 minutes in Mozart condition. And on the next training session on the different day, he first worked on the attention task for 10 minutes in Mozart condition, and then memorization task for 10 minutes in no music condition, and then calculation task for 10 minutes in binaural beat condition. And during the last training, he worked on the attention task in binaural beat condition, memorization task in Mozart condition, and calculation task in no music condition. This way, all participants play all three tasks in different conditions each day. The schedules are created based on Latin squares to ensure the schedules are counterbalanced and minimize the aura effect. So now I will talk about the first task, which is memorization. In this task, the game displays 5 to 7 pictures sequentially, one at a time, like shown on the picture on the right. Then it asks which picture is a fourth picture, varying the number for each question with 4 choices, like in the picture on the left. So players have to memorize the order of which picture appeared. And for this task, we used pictures from the behavioral pattern separation task developed by the Stark Lab at UCI. We recorded and analyzed their accuracy, or how many times they got the correct answer. Accuracy represents their visual memorization ability. So this graph shows average memorization accuracy among all participants by condition. The blue bar is when they are in no music condition, and orange is when they are in the binaural beat condition, and the gray bar is when they are in the Mozart condition. So according to this graph, we didn't see any condition with higher accuracy than other two conditions. We also ran paired sample t-test, but we didn't find any statistically significant difference. So we couldn't get any significant result from this task. Some reasons why we couldn't get the result is maybe because we have small number of samples because we just have 48 students. And also for this task, we had a small number of trials per session. For other two tasks, participants completed more than 100 trials on average. But for this task, participants were only able to complete 40 trials on average because they have to spend 10 to 14 seconds each trial looking at the picture and memorizing them. So because the number of trials were so little, the participant couldn't demonstrate their memorization ability. The third reason is the difficulty. For other two tasks, about like 2 to 30% of participants said the task was very hard or somewhat hard. But for this task, more than 80% of participants said that this task was very hard or somewhat hard, very hard or somewhat hard. So since this task was hard to achieve high accuracy for most participants, we couldn't observe the effect of background music on their performance. So now I will talk about the second task, which is attention task. In this task, it displays 7 drawings of flutes on the screen, like shown on the image. The player is tasked to tap on the flutes with certain colors and orientation. And when they think they got the all correct flutes on the screen, they tap the next button on the right to move on to the next trial. This task is designed based on the Heart and Flowers task developed by Adele Diamond. Just like her task, our task also asked participants to quickly differentiate similar drawings and react to them in order to measure how focused the participants are during the training. And we recorded accuracy, which is a number of times a participant tapped or missed correct flutes, and response time, which is a time taken from when the flutes are displayed on the screen to when the participant tapped on the next button. So we analyzed accuracy and response time, but we didn't see a lot of significant differences between conditions. So we combined the accuracy and response time values into one value called inverse efficiency score, or IES for short. IES is calculated by the average correct response time divided by the accuracy. So as a participant performs more accurately and quickly, the participant had a smaller IES. The graph on the right displays the average IES among all participants by condition. It also compares the performance by the number of target flute on the screen and the color of the flute. The table on the bottom as a result of the paired sample t-test. Overall, there are marginally significant difference between IES in no music condition and the binaural beat condition with p-value 0.064. If we look at the graph on the top, the average IES value in no music condition, marked in blue, is lower than the average IES in binaural beat condition, marked in orange. So on average, the participant completed the task quickly and accurately in no music condition than in binaural beat condition. So the result of this task shows that listening to binaural beats might distract participants from paying attention to the object and quickly reacting to them. However, since p-values are greater than 0.05, the results were not significant enough to get a strong conclusion. If we have a larger number of participants, we might get a more clear differences between conditions. Now I will talk about the last task, which is calculation task. So in this task, the game displays simple calculation problems that are either addition, subtraction, multiplication, or division. And player is given 4 choices, like shown on the image on the right, and have to tap on the button with a correct answer. This task is designed based on symbolic arithmetic tasks developed by all. And we recorded accuracy, which is number of times player tapped on the correct answer, and the response time, the time required by the player to calculate the solution. And we analyzed accuracy and response time, but we didn't get a significant result. So this time, we combined the accuracy and response time into rate correct score, or RCS. Rate correct score is calculated as the number of perfect trials divided by the sum of response time for all trials. This represents the number of perfect trials per second on average. The graph on the right displays average RCS among participants by condition and the calculation type. On the bottom, as a result of the paired sample t-test. Overall, RCS in no music condition and Mozart condition were there marginally significant differences with p-value 0.08. If we look at the graph on the right, the average RCS value in no music condition, marked in blue, is lower than the average RCS in Mozart condition, marked in gray. Therefore, the participant produced more perfect trials per second in Mozart condition than in no music condition. So as a result, listening to a classical music composed by Mozart might help participants to perform calculation problems more quickly and accurately. However, just like the attention task, since p-values was greater than 0.05, the result was not significant enough to get strong conclusion. If we have a larger number of participants, we might get a clear difference between conditions. So as a result, we saw some evidence of effect of music on performance. For attention task, we found out that listening to binaural beats distracted participant from paying attention to the object. And from calculation tasks, we found that listening to classical music helped participants solve calculation problems quickly and accurately. But because of the high p-values, we failed to obtain a strong conclusion about effect of music. So in the future, the following are the things we could change if we repeat the same experiment again in the future. First, we can recruit more participants because this time we just had 48 participants. So if we have more participants, we might be able to get more accurate mean and smaller errors. And second, we can do in-person training sessions. So because of the pandemic, we had to do some training remotely, but because of that, there might be some noise or distraction during the training. So we can ensure that they play the game in the same environment if we do in-person training sessions. And the last thing is we can adjust task difficulty. Like I said before, 80% of participants said memorization task was too hard. So we need to adjust the task difficulty so the task successfully reflect difference in participant performance by background music condition. Thank you so much for listening. And I will stop recording now.
That's not a problem. You don't have to record for the Q&A.